The wheels just retracted. This train is now floating. Nobody builds trains like this. 603 kilometers per hour. The fastest thing ever built that runs on the ground. Started at $9 billion. Now $72 billion. Still climbing. Still being built. They drilled 246 kilometers of tunnel through the hardest mountains in Japan. The geology collapsed. The schedule collapsed. The cost exploded. They kept going. One governor. One signature. He stopped a $72 billion project for 4 years. Japan launched the bullet train. It changed the world. Then Japan asked, what's next? The Tokaido Shinkansen is full. 12 trains per hour. No more capacity. Japan needed a bypass. 1977. The first test track, 7 kilometers in Miyazaki. The first levitation. The first proof it worked. Miyazaki proved it. Levitation worked. Superconducting magnets held. The next step, the Alps. 1990. Geological surveys began in the Alps. 19 years of surveys before a single tunnel was approved. 1,400 meters of overburden, fault zones, underground rivers, rock pressure that crushes steel. Construction could begin. The Yamanashi test track came first. 18.4 kilometers of real maglev railway, built to prove everything. New Austrian tunneling method, drill, blast, shotcrete, rock bolt. Repeat. 11 kilometers of test tunnel drilled. Blast, muck, shotcrete, rock bolt. 6 hours. Every day. A pilot tunnel drilled first, sampling the rock before the main machine commits to it. The guideway must be accurate to millimeters over kilometers. Laser checked, every single section. Figure 8 coils embedded in both walls. Levitation, guidance, propulsion. All in one coil design, frequency power. A dedicated substation built just to supply it. The control center monitors every coil, every sensor, every millimeter of train position simultaneously. The first test train arrived in 1995. No wheels visible, no pantograph. A capsule designed to float.
No wheels touching the track. No overhead wire for power. Everything about this train breaks every rule of railway engineering.
The tires retracted. The train rose, 10 centimeters, floating on in December 1997, 531 kilometers per hour. A new world record. On their very first full-speed test, rode the test train before a single commercial passenger boarded. Japan, October 2014. Ground broken on the real line. 286 kilometers, the biggest railway project in history. Shinagawa to Nagoya, 286 kilometers. 246 kilometers of that, inside tunnels, 40 meters deep, beneath a live railway station, in central Tokyo, without a single delay above. The TBM is assembled underground, too large to be lowered whole, piece by piece in the launch shaft. 4,000 tons, 80 tungsten carbide disc cutters on the face. Above it, homes, shops, people who feel nothing. One concrete ring installed every 90 minutes, 6 segments per ring, 600 then trucks, then disposal, never stops. Where every 50 meters, they must be replaced. Chamber at the tunnel face, one of the most dangerous jobs in construction. A pilot tunnel drilled 1,000 meters ahead, reading the geology before the main machine arrives. Invented this technique for this tunnel. 300 million years old. Emergency redesign, NATM replacing TBM in the worst sections. 5-year delay announced. Lower, costlier, but the only method the 1,400 meters of mountain above. Rock pressure crushing the tunnel like a vice. Engineers designed for it. Tubes installed, then shotcrete, then rock bolts, then more shotcrete. Underground rivers encountered at depth, grouted shut, drained away. The mountain fought back.
3 different tunnel boring methods used in one project: NATM, TBM shield, and conventional drill blast. The geology forced every change.
Fine rock crushed on site, reused as concrete aggregate in the tunnel lining itself. Poured behind the excavation. Each 12-meter pore section takes 3 days. 100-meter vertical shafts sunk through the mountain for ventilation and 60 separate construction contracts, all running simultaneously. One project, 60 different sites. Underground stations carved from solid rock. The Kofu Cavern, bigger than most surface stations. A complete railway station built inside a rock cavity. 40 meters underground, with no natural light. Every guideway section laser surveyed. Tolerance, 1 millimeter over 50 meters. 0 exceptions. 580,000 individual coils installed in the guideway wall. The engine is in the ground, not the train. 246 kilometers of electric motor embedded in concrete, as long, shaped in a wind tunnel for 3 years, designed to enter a tunnel at 500 kilometers per hour. Tunnel entry at 500 kilometers per hour creates a pressure wave. The nose shape took 3 years of wind tunnel testing to solve. Niobium titanium wire, thinner than a hair. Wound 50,000 times per coil, in a vacuum environment. Liquid helium loaded at minus 269 degrees, colder than the surface of Pluto. The magnet becomes superconducting. Below 160 kilometers per hour, rubber tires. Above 160 kilometers per hour, the tires retract. The train floats automatically. Entering a tunnel at 500 kilometers per hour compresses the air violently. The cabin pressure system prevents ear damage. Every sensor verified, every system checked. Before speed is applied. 160 kilometers per hour. Tires retract. The train rises. Engineers at the control center watching the levitation sensors confirm. Each test faster than the last. 200, 300, 400, 500. The data confirming what the physics promised. The U-shaped guideway physically prevents derailment. The train cannot leave the track.
Every test run generates more data than a moon landing. They've run 2 million test miles. Nothing is left to chance.
2 trains passing at 1,026 kilometers per hour combined. The air between them compressed. April 21st, 2015. 603 kilometers per hour. A world record. The fastest land vehicle in human history. Inside at 603 kilometers per hour, almost no vibration. The passengers could read a newspaper. That is the engineering. Full commercial speed testing over longer distances begins. Every train returns here nightly for inspection.
The new governor approved the survey within weeks. After 4 years, construction could resume. The Nankai Trough megaquake could strike any year. The Maglev route is designed to survive it. The 14% above ground uses elevated viaduct, concrete piers, precast beams, the guideway carried on bridges. Above ground or underground, same tolerance. 1 millimeter over 50 meters, no exceptions. China unveiled a 600 kilometers per hour Maglev in 2021. Japan invented this technology. Now it risks losing the race to open first, 2025. A new improved car introduced, lighter, cheaper, more efficient, improving while still building, 2025, 60% of tunneling complete. Shizuoka boring survey approved. Target, commercial operation 2034.